6. We are going to answer a few questions, but before then, it is important to note that when you are solving two simultaneous equations, one linear, one nonlinear, you are likely to get three set of solutions. For example, if you have a quadratic graph intersecting twice with a linear graph, then this one is a case of two distinct roots. And of course, in such a scenario, we have two real roots, two sets of real roots. B squared minus 4ac, which is the discriminant, is obviously greater than 0. You are likely to have a quadratic graph that touches a straight line only one point. This is one repeated root, and this one is a case of the discriminant b squared minus 4ac exactly equals to 0. And you're likely to have a case of such kind of representation whereby the quadratic graph does not even touch the linear graph. This is a case of no real roots is less than 0. You are expected to have no real roots in such a scenario. Why I'm repeating this, which we have had previously, is because we are going to use this information in example 7, in the example 6 rather. Example 6 talks about the line with equation y is equals to 2x plus 1 meets the curve with equation kx squared plus 2y plus k minus 2 is equals to 0 at exactly 1 point. So it is actually this case B at exactly 1 point. Given that k is a positive constant A, find the value of k. Now you can see this one is equation 1, and we call this one equation 2. And we were told that the line with equation 2x plus 1, equation 1, meets this curve at only 1 point. Given that the k is a positive constant, find the value of k. Of course, you can see this one is in terms of y, and there's a y there. And we said in a previous video that when one equation is quadratic and one is linear, then we can only use substitution method. And that means, because we can already see what is the value of y, we need to substitute for y in the quadratic equation. And what does that give us? This one, we write this one in terms of kx squared plus 2y, which is 2x plus 1 plus k minus 2 is equals to 0. We open brackets, you have kx squared plus 4x plus 2 plus k minus 2. And that gives us something to do with, if you follow, you will get kx squared, this term, plus 4x plus 4x, and then we have plus 2 minus 2 cancel out, so we are left with plus k is equals to 0. And this is now the quadratic equation which we should take care of. And at that point, if the two graphs meet only at 1 point, then it means the discriminant of the resulting quadratic equation is exactly equals to 0. So what does that mean? What is the discriminant? B squared minus 4ac is exactly equals to 0 for only one solution. for only one solution. So that means that b is our b is 4. So 4 squared minus 4 times k times k, because our a is k and our c is k. This is what must be equals to 0. If this is true, then we are simply saying 16 minus 4k is equals to 0. And it goes without saying, that 4k squared, rather, not 4k, but 4k squared. It goes without saying that 4k squared is equals to 16. Divide by 4 both sides. Divide by 4 both sides, we have k squared is equals to 4. And k is plus or minus 2. Of course, k has to be plus or minus 2, because the root of any positive number is plus or minus 2. Having said that, we are told that in the question, given that k is a positive constant, so k cannot be negative 2. So the only possible value of k is k can only be 2, because we are told in the question k can only have a positive constant. That is part A of the question answered. Now that this equation meets this equation only once and k is a positive number, we have substituted and solved the quadratic equation, and we have found that our value of k is 2. Look at part B of the same question. For this value of k, find the coordinates of the point of intersection. For this value of k, find the coordinates of the point of intersection. So what does that mean? When k is 2, we need to substitute k being equals to 2 in the quadratic equation that we solved, so that we can get the exact solutions. Meaning that now, substituting k in kx squared plus 4x plus k is equals to 0, meaning that we have 2x squared plus 4x plus 2 is equals to 0. Even if you divided everything here by 2, you'll get x squared plus 2x plus 1 is equals to 0. And of course, when you use AB, when you use B and AC, our B is 2, our AC is 1. Which two numbers we multiply, they give us a 1, and we add, they give us a 2. Of course, that is 1 plus 1. X squared plus x plus x plus 1 is 0. X plus 1 plus 1, x plus 1 is equals 0. If this is true, x plus 1 multiplied by x plus 1 will give you 0. And in such a scenario, you can already see x is equals to negative 1. There is no point of even talking about the next, the other bracket, because it's also going to give you a repeated root. And sure enough, when k is equals to 2, you can have a repeated root, meaning that this linear graph meets this quadratic graph at only one point. And at that point, x is equals to negative 1. But we would also want to see what is the value of y at that particular point. So, substituting for y in the linear graph, we find y is equals to 2 multiplied by the value of x, which is negative 1, plus 1. And y is negative 2 plus 1, which is also negative 1. So these two graphs meet at the point whose coordinate is negative 1. Negative 1. That is the coordinates of the point of intersection. All right?